Today we're going to be talking about arc length and area of sector. And a sector is a region of a circle bounded by two radii and an arc. I think about it kind of like a piece of pizza. So to figure out the length of that, so if I were to measure the actual distance between A and B, not the measure of the arc, we did that in a previous chapter, but to figure out the actual length, well, that's some proportion of our whole circle. Okay, that's some x degree out of 360 of the whole circumference of the circle. The circumference of the circle was 2 pi r. Okay, so if you remember that formula, you remember the idea that it's some fraction or some proportion of the whole length all the way around the circle. And the same idea applies for area of our sector. Our area is pi r squared, so we have some fraction of that whole area. So find the arc length and area of the sector. Okay, so I'm finding the actual distance along our circle, not the measure of the arc. We already have that. So arc length, take the angle we give you, divide by 360. Arc length, remember it's some proportion of the whole circumference, which is 2 pi r. That's going to simplify. Let's leave everything in terms of pi. 8 pi over 3. I have units. Since it's a length unit, it's just regular old inches. Now the area, again, take your 360 over 360 because it's some ratio, pi r squared. So I have 60 over 360 pi times 8 squared, and that simplifies to 32 over 3 pi square inches, because we're talking about a unit of area. So our next example, we have to find the area of our shaded region. So let's take the area of our semicircle and subtract the area of the triangle. So the area of the semicircle is pi r squared over 2 because it's a half a circle. Now we have to find the area of that circle. Now we know, since I have a right angle inscribed in a semicircle, this is a right angle. I should say angle inscribed in a semicircle. That's a right angle. So this is a 30, 60, 90 triangle. So we have to use those special right triangles. So we know the short leg is half of the hypotenuse, so our short leg is 6, and our longer leg is 6 root 3. So the area of our triangle is 1/2 one leg times the other leg. So that's going to be 6 times 6 root 3. Plugging in for our radius, so 36 would be our radius squared. And then here we would have 18 root 3. So the area would be 18 pi minus 18 root 3. And I would want you guys to leave it like that. If you want, you can factor out the 18 and leave it in this form. But I would want you guys to leave it in simplest radical form, not finding me the exact value. Okay, our next example. From point P, PA and PB are drawn tangent to circle O at points A and B. If the radius of our circle is 6 and the measure of APB is 60, find the area of the region outside the circle but inside our quadrilateral. Okay, so let's do this. Let's draw our circle. Okay, so I have a circle. Okay, and I'm going to draw our tangents as best I can. Okay, remember, I'm just trying to draw an idea of what a sketch would look like. That's actually not too bad. I'm going to adjust maybe my points a little bit. Okay, so we have that. We have A and B and point P. The radius of our circle, so from here, perpendicular, is 6. I need to find the area of the region outside the circle but inside our quadrilateral, AOBP. So outside the circle. So essentially, that shaded region. Okay, so let's find the area of AOBP and subtract the area of the sector. Okay, so the area of our whole quadrilateral. If you look at this, we have a right triangle there, right triangle there. If I were to draw in essentially my diagonal, they tell me APB is 60. Now this triangle, the top triangle, AOP, is congruent to BOP by side, side, side. So therefore I know this is 30, this is 30. So I basically have two congruent triangles. So I have two triangles, 1/2 my base times my height. Okay, so I know one of my bases is 6. My height, okay, the shorter leg is opposite the 30-degree angle, so that's 6. The longer leg then is 6 root 3. Okay, and I have two of those. I have the bottom triangle and the top triangle. Now we need to subtract the area of the sector. Now let's talk about how to get the area of that sector. This is a 30, 60, 90 triangle. So therefore this is 60 degrees. This is 60 degrees. So therefore our whole arc is 120. So 120 divided by 360 pi r squared, which is 6. Okay, so simplifying all that out, we get 36 root 3 minus 12 pi. Okay, and I would want you guys to leave that in simplest radical form. Again, if you want to do some factoring, we could simplify this to be that if I factor out a 12, because 12 goes into both 36 and obviously 12, but either one of those would be acceptable. There are your lesson questions. Please make sure those are submitted on time.